As one of the core components of autonomous driving, the target tracking system has been upgraded to a cooperative tracking system enhanced by V2X technology. Cooperative tracking systems track obstacles, predict subsequent movements, and plan future driving paths for vehicles. However, cooperative tracking systems may encounter errors in certain scenarios, and such errors can interfere with vehicle systems and lead to accidents. Therefore, adequate testing of cooperative tracking systems is of critical importance. Adequately testing cooperative tracking systems requires a large volume of data. Practitioners must manually collect data obtained from connected vehicles during real-world road tests, which entails significant resource consumption. Therefore, we have developed a tool named V2X-ATCT, which generates cooperative tracking scenarios with diverse driving behaviors based on real-world datasets. By employing the Cooperative Perception Dataset V2V4 Real and Cooperative Tracking Systems DMS-Track and COBET, we compared the testing performance of newly generated scenarios with that of original ones. Results demonstrate that when encountering these newly generated scenarios, the testing accuracy and precision of the cooperative tracking systems decrease. V2X-ATCT primarily comprises three modules: coordinate calculation, scenario generation, and inaccurate localization guided V2X cooperative tracking testing. The coordinate calculation module incorporates three driving behaviors: overtaking, turning, and vehicle following. Each driving behavior is associated with specific constraints, which mathematically describe the relationship between positional information and driving conditions. By leveraging the Z3 solver based on these constraints, we compute precise positional information, which serves as the foundational input for subsequent scenario generation. In scenario generation module, after computing the position information, the module invokes a simulated LiDAR to render the entity vehicle at the specified position, generating point clouds. All occluded points are removed. Finally, corresponding vehicle point clouds and labels are generated. The guidance strategy of the module aims to generate low detection accuracy scenarios from cooperative vehicles' viewpoint while maximizing confusion in the cooperative perception system. Since the cooperative tracking system relies on object detection results, poor detection performance degrades its outcomes. Therefore, we design a guidance metric, AVIOU, to measure the likelihood of test data that reveals errors. V2X-ATCT offers the following main functions: scenario generation and corresponding result display, experimental computation, and result visualization. In the scenario generation module, users can select parameters such as scenario type, driving behaviors, number of inserted trajectories, vehicle speed, etc. Then click the Generate button to start the generation process. Note that you must wait until the system displays over and no errors are reported before the process is considered complete. Once scenario generation is finished, users can view the generated scenario data. The experimental module is divided into RQ1 and RQ2. Taking RQ1 as an example, multiple parameters can be adjusted. After configuring the desired settings, click the Generate button to begin computation. After the experiment completes, users can view the results. For more detailed tutorials, for instance, on scenario visualization, please refer to our GitHub repository. In the end, let's take a look at the visualizations of the three driving behaviors.